All right, let's dive into something pretty cool today. We're going to talk about the smart shortcut that lets game AI think circles around us, a really clever trick called alpha-beta pruning.
Have you ever played a game against a computer, maybe chess, or even just tic-tac-toe, and it just feels like it knows what you're gonna do before you do? Like it always has the perfect counter? Well, it's not magic. It's all about thinking ahead, and we're gonna break down exactly how that works. So at its heart, the AI's goal is actually pretty simple. It just needs to look at all the possible moves it can make and pick the single best one. But, and this is a big but, it has to do this assuming that you, its opponent, are also going to make your best possible move. It's like a duel where both sides play perfectly. Okay, so the classic way to solve this puzzle is with an algorithm called minimax. You should think of this as the brute force strategy. It's super logical, but its whole game plan is to look at every single possible move and every counter move and every possible outcome that could ever happen from this point forward. The way it works is by setting up two imaginary players. First, you've got the max player, that's our AI. Its only goal in life is to maximize its score, or what we call its utility. Then you've got the min player, that's you. Your goal is the exact opposite, to minimize the AI's score. So every single turn is this constant tug of war. So how does this actually play out? Well, first, the AI generates this massive game tree, which is just a map of every possible move sequence. Then it goes all the way to the end of every branch and gives it a score, like +1 for a win, -1 for a loss, 0 for a draw. And then, this is the really important part, it works its way backward from those endings, always assuming that max will pick the move with the highest score and min will pick the one with the lowest. Okay, so that sounds pretty foolproof, right? Just check everything and you're guaranteed to find the best path. So what's the problem? Why don't we just use this for every game out there? Well, the problem, and it's a huge one, is something called exponential growth. With every single turn, the number of possible futures the AI has to calculate doesn't just add up, it multiplies. It explodes into an absolutely unmanageable number of paths, and it happens really, really fast. To put this into perspective, let's just take a look at chess. On an average turn, a player has about 35 possible moves. Over a whole game, the number of possible board positions is something like 35 to the power of 100. That is a number so ridiculously huge, it's bigger than the estimated number of atoms in the entire observable universe, no joke. And that right there is the nail in the coffin. For a complicated game like chess or Go, trying to explore every single path isn't just slow, it's completely, fundamentally, computationally impossible. Not even for the biggest supercomputers on the planet. So Minimax is a great idea in theory, but it's just not practical. So if brute force isn't going to work, we need a smarter strategy. And this is where alpha-beta pruning comes into the picture. You see, while Minimax just blindly plows through every single option, alpha-beta is way more clever. It intelligently ignores entire sections of that game tree because it knows they're worse than an option it's already found. So what is it, really? Alpha-beta pruning is just an optimization, a clever upgrade for Minimax. Its whole job is to prune, or, cut off, branches of that huge game tree that it can prove are totally irrelevant. It's a shortcut, yeah, but it's a mathematically perfect one. And the whole trick relies on keeping track of just two values. First is alpha. Think of alpha as the best score, the highest value that the max player is guaranteed so far. And then there's beta, which is the best score, so the lowest value that the min player is guaranteed so far. And this, right here, this is the secret sauce. This is the entire magic trick in one sentence. The golden rule is, the moment alpha is greater than or equal to beta, you can just stop searching down that path. Let's see why that works. Okay, let's make this real. Let's walk through a quick example. Imagine our AI, the max player, is looking through that game tree, and it finds a path of moves that guarantees it a score of at least 10. So boom. Since that's the best outcome we've found so far, we set our alpha value to 10. That's our new baseline. We know we can get a 10. The question is, can we do even better? So now, the AI starts looking down a totally different branch of the tree. And on this new path, it finds a spot where the opponent, the min player, can make a move that forces the final score down to just 3. Now, from the min player's perspective, forcing a score of 3 is way better for them than letting us get a 10, right? So along this branch, min knows it can hold us to a score of 3 or maybe even less. So for this branch, the beta value gets set to 3.
So here's the big question. Our AI, Max, already knows it has a guaranteed path to a score of 10. It's now looking at a new path where the opponent can force it down to a 3. Does it even need to bother looking at any other moves down this new path?
Well, let's check our golden rule. Is our alpha, which is 10, greater than or equal to the beta on this branch, which is 3? Yep, it absolutely is. And because of that, pruned. That entire branch of the tree just gets cut off. The AI doesn't look at it anymore. And why? Well, it's simple. It already knows it can get a score of 10. Why would it ever choose a path where the opponent can guarantee it'll get a worse score? It wouldn't. It's a perfectly logical shortcut. And this is the most important thing to get. Alpha-beta pruning isn't finding a different answer or a good enough answer. It will always, always give you the exact same perfect move that the slow, brute force Minimax would have found. It just gets there in a tiny fraction of the time.
And how much faster are we talking? Well, in the best case, alpha-beta can effectively search twice as deep into the game tree in the same amount of time. Now, twice as deep might not sound like a lot, but in a game like chess, that difference is absolutely colossal. It's the difference between an amateur player and a grandmaster.
And really, that's the whole story. Alpha-beta pruning gives you the same perfect, optimal decision that you'd get from checking every single possibility. It just does it intelligently, efficiently, and frankly, it's what makes modern game AI possible at all. So this leaves us with a pretty fascinating thought. The core idea here is about finding the best solution without wasting time on all the bad ones. If we can teach an AI to find these kinds of elegant shortcuts in games, just imagine, where else could this kind of smart, predictive efficiency completely change our world?